My name's Shane, and today I'm going to show you how to populate the IEA Wind Task 43 Wind Resource Assessment data model for a newly created station on BrightHub. And to avoid that massive mouthful, I'm just going to refer to it as the data model going forward. So first off, let's log in and let's navigate to a newly created station. Here's a demo site in Pakistan, then setup, then edit station setup. So here we're presented with the data model view. The data model is a machine-readable international standard that captures all of the metadata that describes how a station is set up and how it changes through time. So why is this important? Well, if we export the data model and the raw data from BrightHub and import this into third-party software that recognizes the data model, then that software will also know exactly how the station was set up and how it changed through time. This significantly reduces your time transferring data between different pieces of software and also processing and analyzing that data. Not just that, the data model allows and permits the building of automated workflows on top of your raw data. This will be described in later videos on BrightHub. Jumping in, we have the measurement location view. So here, the latitude and longitude is automatically pulled directly from the raw data files. You can check this and modify it if you wish. There's also a name pulled out of the raw data files, which you can also modify and give a unique name on BrightHub. Because of this logger file being an aminate, it automatically knew it was a mast, and you can add some notes, and also you can add in some additional mast properties, mast geometry, OEM, mast serial number, etc. Next, we have the logger main configs. BrightHub has gone through all of the historical files looking for high-level logger configuration changes through time. Here, if there's more than one line, it indicates that there has been a logger configuration change. And if we look across, we can see that the logger model is the same, the logger serial number is the same, and the logger ID is the same, as well as the logger name. So the logger hasn't been changed. However, there was a change on the 8th of February 2017. So scanning across, we can see that the only change appears to be a UTC offset change from +5 hours to 0 partway through the record. This is a very important detail for an analyst to understand so they can make post-processing adjustments to the data to account for this. Next, we go to measurements. The data model is structured that there is a geographic lat-long location where your station is located. Then there is a measurement point, which is a point in space above that location with an associated measurement type. For example, a wind speed, a wind direction, or temperature, or pressure at a given height. That measurement point is independent of the sensors associated with it, and also the data column names in the raw data and the logger measurement configs again. The reason why these are all separate entities is that they all can change independently of each other and they have to be treated separately. For instance, we have a measurement point with a sensor, example, the 80 meter wind speed with an anemometer associated with it. Partway through the record, that anemometer could fail and then be replaced. And therefore, there'd be two sensors associated with that single measurement point. Equally, a sensor can get moved on the same mast from one measurement point to another. Separately, in terms of the data column names and the logger measurement configs, for example, an OEM installer could visit the site to do some maintenance on a logger, remove the wires from the logger and then reconnect them at the end of the maintenance, and accidentally reconnect the 80 meter wind speed to the 60 meter channel. Suddenly, you've got your 60 meter columns, raw data columns in your data, recording 80 meter wind speeds. So the data model can account for all of these changes and then modify the data appropriately to give you consistent data, tracking what's happened through time. Next, we jump to data column names. Here, you will see that these are all of the column names that are extracted from the raw data files. And if you look down here, you can see that there is 102 columns in the raw data files. And we can scan through them like this, or we can show more rows if we wish. And below that, we can see the column groups. So here, BrightHub has grouped for a particular measurement point, the raw data columns that are associated with that point, such as the average, standard deviation, max, min, and count. BrightHub, because it's working smartly with your raw data, has done this automatically for you. So it has grouped all of the relevant statistics together per measurement. This makes it really powerful, and it saves you a lot of time than if you had to do this manually. Next, we jump to logger measurement configs. Here, we associate the measurement point with the column name groupings from the data column names, and we also see what was pulled out or what was programmed into the logger for that particular measurement point. In this case, you can see the logger slope and offset here. And scanning down, you can see that when there's a date 2, it means that there's been a change to that particular measurement point within the logger. So looking across here for speed 5, we can see that this represented the 20-meter wind speed, and the column names haven't changed, yet the date has changed. So scanning across further, we can see that the logger slope is the same, yet the logger offset has changed. This signifies that the mast installer must have visited the site and updated the logger offset within the logger. But this is actually a very important thing for us to know when we're looking to apply and assess the calibrations applied to this instrument. Next, we go to sensors. Here is the list of sensors that BrightHub has extracted from the raw data files. If we look down here, we can see there's 12 in total. Straight away, you can see it knows the sensor OEM, sensor model, and the sensor type based on what has been programmed into the raw data files. However, it doesn't know information like the serial number, calibration slope and offset, and other information that you typically extract from an installation report. However, you can add that easily by just typing in the serial number here, and then if you wish to add the calibration slope and offset, just pressing this plus sign. Here we can add in the type of measurement that it is, whether it's a wind speed, wind direction, etc., the calibration slope and offset, calibration organization, place of calibration, and even the report file name for full traceability. Then we can go down to mapping the sensors. Here we map those sensors that we have populated above to a particular measurement point. Again, BrightHub does this for you to make it as easy as possible. But remember that speed 5 that we mentioned? It picked up on a logger change halfway through the logger record. It has automatically pulled out those 2 points here and created 2 separate teeth anemometers associated with that one measurement point. So here what we would have to do is add a date to, and then from date from, and associate the same instrument to both. But again, it makes it very simple to do so. Next, we go to mounting arrangements. Here, we populate all of the metadata associated with a particular instrument around its mounting. This is particularly important for anemometers and wind vanes to ensure consistency during the measurement record. For instance, we could put in the measurement point associated with a particular anemometer here, the mast section geometry, whether it's tubular or lattice, the date from and date to that mounting arrangement existed, mounting type, was it side mounted or top mounted? If it's a wind vane, it's wind vane deadband orientation. Is that orientation reference to magnetic north or true north? And then other really important information like the boom orientation, especially for wind vanes. And then finally, boom length, boom diameter, upstand height, upstand diameter, etc. The information that's really important to understand if you want to validate the IEC compliance of a certain mounting arrangement. So all of this can be captured here for the critical instruments like your, as I mentioned, your anemometers and wind vanes. Next, we can capture some interesting information about interference structures. Interference structures are structures that can affect the wind flow around a particular instrument like an anemometer. Things like a lightning rod or a guy wire, for instance. This isn't typically an issue, but all that information can be captured here, and then you can map that particular issue to a particular measurement point. That concludes our presentation on how to populate the data model on BrightHub. Please follow BrightWind on LinkedIn to hear more about updates and interesting information on BrightHub.